your solutions to review number 5. Again, make sure you have done these before watching the video. If you haven't, you should be doing them. Maybe do the first page, then watch the first page, then do the second page, watch the second page. You really want to make sure you can do them, not just, if you're just watching me do them for the first time, I can make it seem easy. And you might seem like you know what you're doing, but you really need to test yourself to see if you do know what you're doing by trying it first, so you could tell what mistakes you make. You make a mistake on the review, you probably won't make the same mistake on the practice. You don't do that ahead of time, you're only cheating yourself, I'm telling you right now. All right, so 9 minus 2i squared. Remember, we don't square these individually. 9 minus 2i times 9 minus 2i, that's what it means to square something, multiply by itself. 9 times 9, 81, minus 18i, minus 18i again, and then negative 2i times negative 2i, positive 4i squared. Positive 4i squared. Careful there. I squared, you're going to see that a lot here. I squared, we know, is negative 1. You have to know that. 4 times negative 1 is negative 4. 81 minus 4, 77. And then this combines for minus 36i. All right, 77 minus 36i. You might put 0i if you get trapped into thinking those cancel out. All right. Because it's multiplication, we could just go and multiply this. And we add exponents. So it's 15i to the 31st. We don't ever leave a power of I, so we're going to take that 31 and we're going to do long division by 4. 4 goes into 31 7 times with a remainder of 3. So I to the 31st is really I to the 3rd. So it's 15i to the 3rd. Again, I to the 3rd because of the remainder of 3. Now, you're supposed to know that I to the 3rd is negative I. So this is 15 times negative I. And 15 times negative I is negative 15, which is choice C. Vertex form. Put a Y there. Get rid of the 11. Y minus 11 equals x squared plus 8x. Sorry, minus 8x. Minus 8x. And then half of 8 is 4. Squared is 16. So we're going to add 16 to both sides. Y plus 5 equals, this is going to be x minus 4 squared, x minus 4, and then subtract your 5 over. So y equals x minus 4 squared minus 5, choice A. Identify the vertex, well that's easy, we just did that in the other problem actually. So opposite of 4, negative 4. And then same, keep that the same, negative 3. You guys are pretty good at that now. That was a pretty easy one. And then if the discriminant, discriminant. If the discriminant of a function is 35, then the solutions are what? Think about what the discriminant is. The discriminant, by definition, is something that distinguishes something. What we talked about in the lesson video, something that's distinguished amongst other somethings. Okay, so what is that 35 when talking about quadratics? That 35 is the number under the radical. So if you have x, I'm just going to write out the quadratic formula. X equals negative b plus minus radical b squared minus 4ac over 2a. When you do the quadratic formula, and again, I don't even have enough information to do the quadratic formula, but that 35 is the number under the radical. That b squared minus 4ac part, that right there, that is 35. So I'm just going to, what do I want to do? I want to just erase that under there. And that b squared minus 4ac is really, in this problem, is going to be a 35. A 35. That's what the discriminant is. Now, what does that mean for the solutions? Well, it's a positive number, so we're not going to get complex. We're not going to get complex solutions because that would only be for a negative number. The only way you're going to get one solution, one repeated solution, is if that number is a 0. We talked about that, so it's not that one. So we're down to two solutions, because you have plus minus, right? Rational or irrational? Well, the square root of 35 is an irrational number. If you put that in your calculator, you're going to get some decimal that goes on forever. If this was like a 25, then it would be just 5, so that the solutions would come out nicer, would come out rational. Or I said nicer, which would be rational. This is going to be the ugly, irrational numbers, decimal that goes on forever, so that would be choice C here. Whenever it's a non-perfect square number, you get irrational solutions. Your solution, A plus BI form, so we're going to have to rationalize our denominator. You can't leave an I, you can't have an I in the denominator. So to get rid of that I, because it's a binomial, you have to use the conjugate, 3 plus I, kind of like how we did the radicals, except I instead, right? Okay, so we're going to have, distribute 15. We have 5i and 6i, so that's going to be, I'll just write out 5i, 6i, and then 2i squared. 2i squared. Don't forget that square. 2i times I is 2i squared. That's where a lot of students make mistakes. 3 times 3 is 9. Minus I times positive I is negative I squared. Okay, so I have, now, I squared is negative 1. So this term is negative 2. 2 times negative 1, negative 2. 15 minus 2 is 13, plus 11i. And then I have 9, and again, I squared is negative 1, so this is negative negative 1. Negative negative 1 is plus 1. 9 plus 1 is 10. If you didn't get that, rewind, watch again. I explained it. Evaluate the discriminant. And use that to predict the nature of the solutions. Discriminant is just going to be the b squared minus 4ac. So we're going to do b squared minus 4a is negative 2, and then c is negative 7. So that's going to be 36 minus 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 is minus, and then 56. So I have 36 minus 56, negative 20. My discriminant is negative 20. So again, what does that mean? Well, if I did the entire quadratic formula, negative 20 would be under the radical. I don't even know what b, well, I do know what b is, and I do know what a is, but whatever. So you put in your 6 there, and you put in your negative 2 there. That doesn't matter. The radical is what controls the nature of the solutions. Because it's a negative, you're going to have exactly 2 complex, non-real solutions. You can't have one complex solution. It's always 2. Imaginary, non-real, complex solutions. This one's a little ugly. So I'll break down my radical here, 48. I'm just going to break down 48 over here, just on the side. 16 times 3 is what I came up with, and then 16 is 4 times 4. All right, so 4 radical 3. Got it? Now 4 times the 6 that's already there gives us 24 radical 3. Now this, you got to do a little thinking here, guys. Radical, I'm just doing this on the side again. Radical 1 over 3 is radical 1 over radical 3. Okay? Now radical 1 is square root of 1. Square root of 1 is just 1. So this is 1 over radical 3. Got it? 1 over radical 3. This is 1 over radical 3. 2 times that is 2 over radical 3. So, again, this radical 1/3 is 1 over radical 3 times 2 is 2 over radical 3. The problem is I don't have a common denominator. To get a common denominator, I have to multiply by the denominator, radical 3. So I'm doing that here. So that gives me a radical 3 times a radical 3, which is 3. 3 times 24 is 72. And then plus 2 over radical 3. Now I'm going to erase this because I don't need it anymore. And that's going to be 74 over radical 3. And then, of course, we don't leave radical 3 in the denominator. we get 74 radical 3 over 3. 74 radical 3 over 3. Determine all the solutions. Now, there's a mistake on this problem, but I'm not going to change it now. See how it says complex numbers and then a plus bi form? That's kind of telling you you're going to have complex roots, but these actually don't. There's a typo. It should have been +4, but that's okay. We're going to leave it the way it is. We're just going to solve it. How would you solve this? You would just use the quadratic formula. So negative b. This is really just practice in solving using the quadratic formula. Negative b. Let me write this out for you guys, because you guys are always like, I don't know it. Negative b plus minus b squared minus 4ac over 2a. All right, so I'm plugging in b squared would be 16 minus 4ac. That's negative 4 over 2a. All right, so that's going to be, where are we at? 4 plus minus, this comes out to be 96 over 10. And that comes down to 4 plus minus 4 radical 6 over 10. And then 4, 4, and 10 can all divide by 2. So that's 2 plus minus 2 radical 6 over 5. Simplify. All right, so we have 3 times 4. That's going to be 12. 3 times negative I, negative 3i, plus 8i. And then 2i times negative I, negative 2i squared. And then distribute here, 30i minus 12i squared, and then plus 8i. So now, basically, guys, first thing you want to do is get rid of those I squareds. You don't want powers of I. Any I squared is a negative 1. So, all right, we got 12. Let's do that first. One thing at a time. Now, this is negative 1 times negative 2, so that's plus 2. 30i. Here's another negative 1 times negative 12, so that's plus 12. See, that I goes away. I squared is just negative 1. Negative 1 times negative 12 plus 12. Now I'm combining like terms. 12 and 2 and 12 is 26. And then 8i, 30, and 8 is 46i. Is that right? 46i. 8i and 8i. 30, yeah, 46i. 40. Oh, and there's a minus 3i here. Minus 3i. Okay, so 46i minus 3i. 43i, you should get 43i. I almost forgot about that little minus 3i there. Okay. See, easy to make mistakes. Even I made one there. Create the equation of parabola in vertex form if the focus is negative 4, 1, and the directrix is y equals 5. First thing you got to do, you got to think about, does this parabola open up or down? That's going to determine where the directrix is compared to the focus. Because the focus is at 1, a y value of 1, and the directrix is a y of 5, which is above the 1. Sorry, the 1 is here. The 5 is above the 1. So the directrix is 5. The focus is 1. That directrix is above the focus. I'm going to draw that. My directrix, y equals 5, is above the focus of negative 4, 1. So my parabola must open down. There's my vertex. My focus is negative 4, 1. Okay? So what do I need? I need my p-value. I need my p in order to get my a. My p-value is the distance here and the distance here. Well, if this is a 5 and this is a 1, this must be 3. So the vertex, we need that too. My vertex must be negative 4, 3. 3 is in the middle of 5 and 1, right? And then, of course, what's the distance between 5 and 3? Well, it's 2. The distance between 3 and 1 is 2. So my p-value is 2. My vertex is right there. And now I can find a. A is 1 over 4p. A is 1 over 4 times 2. P is 2, right? So 1/8. Now I got a. I got my vertex. I can do my vertex form of my parabola. Y equals vertex form, x something squared something. All right, my a value is 1/8, but the parabola opens down, so it's negative 1/8. I got to squeeze that in here. y equals negative 1/8 x plus 4. Remember that x value gets changed when you do a vertex form, and then plus 3. So y equals negative 1/8 x plus 4 squared plus 3 would be my vertex form. Determine a third degree polynomial with zeros at 2, 4, and negative 7. All right, well, that's pretty simple. So a function, so f of x equals, we're going to have to go x minus 2. If 2 is one of the zeros, x minus 2 is a root. If 4 is one of the zeros, x minus 4 is a factor. I mean, x minus 2 is a factor, x minus 4 is a factor. If negative 7 is a root, x plus 7 must be a factor. So there it is. And it's third degree, so I only need the 3. I don't need the multiplicity. I don't need to square anything. So there we go. And then standard form. Okay, this is factored form. Standard form, you're going to have to multiply all this out. Ugly, ugly, ugly. What I did was it doesn't matter the order you do it. I left the x minus 2, and then I said this was x squared plus 3x minus 28. X squared plus 3x minus 28. Then I set up a table. I did tabular method. Nice review here of our tabular method. I did x minus 2, and then I did x squared 3x minus 28. So I got x to the third minus 2x squared plus 3x squared minus 6x minus 28x plus 56. And that gives us f of x equals x to the third plus x squared and then minus 34x and then plus 56. That's standard form. All right, 2 more. Given the function, identify the vertex. Well, we already know that. It's negative 4, negative 2. The focus. Okay, so the focus, let's draw this out. We have a vertex, and we have, it opens up. It opens up. I know my vertex is, let me do it over here. My vertex is negative 4, negative 2. I know I have a focus up here. And now, I need to know how far up and down to go. See, that's the thing. To get the focus and the directrix, from that vertex, how far up, how far down do I go? That's the p-value. P is based on A. A is right here. A is 1/4. P is 1 over 4A. 1 over 4 times 1/4. So it's just 1 over 1, which is 1. 4 times 1/4 is 1. 1 over 1 is 1. P is 1. So my distance is 1, 1. So I go up 1, down 1. Up 1 to the focus. That's going to be negative 4, negative 1. If I go negative 2, and then I go up 1, I'm at negative 1. So my focus is going to be negative 4, negative 1. And then my directrix, I go down 1. That's going to be the line y equals negative 3. Y equals negative 3. Use the distance formula to show, definition of a parabola. At this point, by definition of a parabola, that's when so it's where's 2, 7? 2, 7's like right here. We have to show that that is equidistant to the focus and to the directrix. Remember we talked about that? Equidistant to the focus and the directrix. Well, we already know that it's a distance of, okay, so this is 7, 2, 7, right? So 7 to the directrix. Sorry, to the directrix. 2, the 7 to negative 3. Let me draw this again here. Say 2 7's right there, right? Here's my directrix. Pretty bad directrix. This is 2, 7. And this is at y equals negative 3. So I'm going from 7 to negative 3. From 7 to negative 3, that's a distance of 10. 7 minus negative 3. And this is how you can show it on your test if you had to do that. 7 minus negative 3 is 10. There's a distance of 10 from that point to the directrix line. How about to the focus? Well, you're going to have to use the distance formula. So distance between 2, 7 and the focus we said was negative 4, negative 1. Distance, formula, subtract the x's, 2 minus negative 4, squared. Subtract the y, 7 minus negative 1 squared. That's going to be 6 squared, 36. And that's going to be 8 squared, 64. And that's radical 100. And that's 10. So see how the distance from the point to the focus is the same as the distance from the point to the directrix. That's the definition of a parabola and how you would prove that. Given these 3 points with this, y equals blah, 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 set up your system of equations. We've done a bunch of these. All right, so it's going to be 4 equals a plus b plus c. Then it's going to be negative 10 equals 9a plus 3b plus c. And then 2 equals negative 1 squared is 1. So a minus b plus c. So there's my system. What I like to do, guys, is I like to take that middle equation. See how I have c, c, c? All you need is one negative c, and that's going to make your life a lot easier. So what I'm going to do is change all the signs on this middle equation here. This is one way to do it. Again, you may not have done it the same way I did. All right? So there we go. I do that, and now I know the first 2 equations give me an AB, and the second 2 equations give me an AB. So I have, if I combine the first 2 equations, I get 14 minus equals negative 8a and then minus 2b. If I combine the second and third equations now, I get 12 minus 8a minus 4b, and then again the c's drop out. Now I have a 2-variable system. All I need to do is I almost have the same a's here. How about just negate the a's here? Multiply by negative 1, right? That's going to give me minus 12 plus and then plus. So that's going to give me 2 equals, drop out, 2b. b equals 1. All right, good. B equals 1. Now plug it in here. 14 equals negative 8a minus 2 times 1. You can plug it in anywhere, really. This is minus 2, add 2. 16 equals negative 8a, and then a is negative 2. So a is negative 2, and then c comes out to be 5. I'm just going to save you time here. C comes out to be 5. You just plug, you plug the b and the a, and I think you guys know how to do that. So my final answer, ready? P of x equals a negative 2 x squared plus x, because it's 1, plus 5. All right, last one. A function p of x equals x to the 4th minus 2x to the 3rd minus 20x squared plus 42x plus 171. Has a repeated solution of x equals negative 3 with multiplicity of 2. Basically, what that means is, and I put it in parentheses here, x equals negative 3 is a solution twice. So you have x equals negative 3, x equals negative 3. It's a repeated root. So instead of having like negative 3 and 5 or whatever, it's negative 3 and negative 3. There's 2 of them. How many solutions does p of x have? How do you know? Well, the number of solutions, remember, is equal to the degree of the function. So the degree is 4. The degree is 4, so there are 4 solutions. 4 solutions. How do I know? Explain how you know. You would just put the degree of the function. The degree of the function. That will tell you how many solutions you're going to have. Now, they may not all be real solutions. That we're going to find out here. All right, so identify all solutions of p of x equals 0. That means solve, basically solve for x. Solutions of p of x when it equals 0. So we're going to say p of x equals 0. 0 equals this. We're going to put a 0 in there, right? Make that equal to 0. Okay, look at this crazy long equation. How are we going to solve that? We can't. We can't factor that. That's a mess. So we have to use our solutions to break it down. And we're going to use synthetic division to do that, to help us. I mean, you could use long division if you want, if you're crazy enough to do that, but much easier to do it with synthetic division. Take your coefficients here. All right.
and run your synthetic division through. So we have 1, -3. We all know how to do this. 15, -5, 15, 57, and then 57 times -3 is -171. Voila, look at that. We get our 0. So now we're down to, if we put this back in, remember you drop down a degree, so it's x to the third. This is x to the third minus 5x squared minus 5x plus 57. Still cannot be factored. So we're going to keep going. Do we have another root? Do we know another solution? Yes, we do. There's 2 x minus 3's, remember. There's 2 of them. So let's do another -3. Do another -3. Run that through the synthetic. (24, 19, -57, 0). There we go. So here we go. 1, -8, 19. That's x squared minus 8x plus 19 equals 0. Can we factor that? No, we can't. 19 is only 19 times 1, and you're never going to get 8. However, it's quadratic, right? It's got x squared. So we can now run it through the quadratic formula. X equals -b, so 8 plus minus, and I'm going quick here because you guys should know this. B squared would be 64. Yes, I skipped a little bit there. We should know what we're doing. AC, A is 1, and I'm going to write it. Divided by 2. 2A, A is 1. So we have 8 plus minus radical -12 divided by 2. Eight plus minus, now we should know how to break down radicals by now. 12 is what? 6 times 2. 6 is 3 times 2. So we have a pair of 2's. Oop, the 3 shouldn't have been circled. Pair of 2's. 2i radical 3. Where'd the I come from? Well, it's a negative under the radical, right? So 2i radical 3, that 3's left over 2. And that breaks up 8 over 2 plus minus 2i radical 3 over 2. And now we can simplify. 8 over 2 is 4. 4 plus minus, and then the 2's reduced to 1, I radical 3. So we have 4 plus minus I radical 3. There's my other solution. So I have 4 solutions. I have -3, -3, 4 plus I radical 3, 4 minus I radical 3. 4 solutions like we said we were going to have. Express P of X in terms of linear factors. Let's do that. So P of X equals, okay, well we had -3, -3, so that's going to be x plus 3, x plus 3. The other linear factors are going to come from this. X minus 4 plus I radical 3 and x minus 4 minus I radical 3. They're both minus, x minus, because the 4 is positive in both of them. It's 4 plus I radical 3, 4 minus I radical 3. The 4 is positive, so when you put it in the factor, it's going to be -4. You know how the sign changes, right? All right, we did that before. So there's my P of X written in terms of linear factors. How many x-intercepts does a graph have? Only real solutions are x-intercepts. We have 2 real solutions. However, but it's repeated. So this is only going to have 1 x-intercept. 1 x-intercept. 1 x-intercept. Okay. X equals -3. That is the, and then you just put only real solution. It's the only real solution. Therefore, it's the only x-intercept. There's 2 of them, but it's repeated, but it's the same on a graph. It's just the same point. It's -3. So the graph's going to hit -3, and that's it on the x-axis.